All right. Hello, everybody. Welcome to day 2 of the US-based live panel discussions. It's my great pleasure and huge honor to present to you today today's panel, where we are hoping to discuss on how will we live in space and what do we still need to really make that happen for long-term missions and future long-term life in outer space. Brief housekeeping, please try to mute yourself if you're not talking, and for all the people in the audience, please use the chat function for any questions. If we don't get to it, I'm sure that our panelists also keep an eye on the chat, and they're free to also answer some of the questions throughout. We do only have an hour, and to be fair, with this panel, we could probably speak for 3 weeks and not run out of topics. So we will only be able to touch on certain things for sure. It is, again, my great honor to welcome everybody. I also want to give a brief shout out to today's LGBTQ plus in STEM Day. And I know that most of our speakers are heavily involved in efforts for diversity and inclusion. So thank you for that. And with that, we are going to start off. I'm going to briefly introduce myself. I'm Christine Maynor, or Chris. I work at the Mayo Clinic in Jacksonville, Florida. I'm an assistant professor for biomedical engineering with medical background and then a background in biochemistry. And for the past 3 years, I'm working on developing small devices and hardware to test human cells in space. And with that, I am going to start the introduction for our great panelists. And I will call them out individually, and then they have the floor for a couple minutes for a brief introduction of themselves. With that, I would like to start with Dr. Dorit Donoviel. She's an associate professor at the Baylor College of Medicine. She's also the director of the Biomedical Innovation Laboratory. Innovation is also something very close to my heart. So very excited. She is the executive director of the Translational Research Institute for Space Health, or Trish, and has herself launched successfully many different programs to facilitate commercialization and nascent technologies and products to improve healthcare in space and on Earth. It's a really great honor to have you here today, and please take the floor and introduce yourself and share some more about your work and perspectives. Thank you.
Thanks for having me, Christine. It's really an honor, and I'm so excited because it truly is a global effort, and having people join us from all over the world, folks down under, for the work that we're going to do up above together. So space exploration, as everybody knows, is a global effort. So Trish is really lucky to be partnered very closely with the Human Research Program. And our job really is to take advantage of opportunities that are in emerging markets and scientific discoveries, as well as new paradigms and healthcare models, and develop the capability to keep any human, no matter what their background or their personalized medicine needs, healthy in space. As we think about further going out away from low Earth orbit, the challenges become greater, and we have a ways to go in terms of mitigating the risks to human health, even things as simple as food. And so Trish is partnered with the Human Research Program through a cooperative agreement for 12 years. We are in our 6th year of operation. We have consortium partners out of Baylor with Caltech and MIT, and people embedded in those communities. And we basically look to find and fund nascent research, really groundbreaking research in health and medical and human performance capabilities. So I'm really thrilled to be here today and to talk about all the things that we're going to do together, not just to make sure that humans are healthy in space, but also bring those innovations back to Earth to change the way we do things. We get to reinvent how we live life on Earth here with what we do in the work for space. So thanks for having me. I look forward to the panel.
Thank you. That's really fantastic. And as we continue with our introductions, I would like to introduce Dr. Emmanuel Yoqueda, who is also a medical professional, assistant professor for emergency and space medicine at Baylor College of Medicine. And he is the current chief medical officer and interim chief scientist at Trish. And with that, please take it away and share some more about your work.
Thank you, Chris, and thank you everybody for joining us today. Really excited. I echo what Dorit said, having people from all over the world. This is exactly what we need to make sure that human spaceflight is not only good for everybody, but also representative to everybody. So we need to hear from people from all over the world, all backgrounds, all diversities, all genders. So I'm absolutely excited to be here today. So I think Dorit did a great introduction about Trish, but one of the newest initiatives that we have been developing for the last 6 or 7 months is commercial spaceflight. And I'm sure that all of you have heard about all of the people who have flown into space, all the civilians that have been into space for the last few months. And we have seen really the youngest and the oldest person. We have seen a very diverse crew during the Inspiration 4 mission. And in my professional opinion, this is really the new chapter of how space is going to look in the future and how diverse it is going to look for all of us. So we at Trish are very, very fortunate to be working in commercial spaceflight with a lot of the commercial spaceflight partners and with the spaceflight participants with the end goal of, again, making this more diverse. And going back to what Chris was saying at the beginning of this presentation, how can we do a little bit to ensure that in the future, spaceflight is going to be accessible for everybody, not only going to low Earth orbit, but even thinking on how can we make habitats in other planets and how we can make life possible in other planets. So really happy to be here today, and thank you.
Fantastic. We're honored to have you. So next up is Dr. Malika Sama. She's a postdoctoral fellow in the Human Spaceflight Lab at Johns Hopkins Medical University. She is studying how human adaptation and acclimatation to extreme and novel environments could help, and works on stress and resilience, neuroendocrine system, and behavior. I'm really excited to have you join us here and share some about your work and your experience.
Muted. You would think after a year and a half of doing only Zoom meetings, we'd figure it out, but still a struggle. Hi, everyone. Thank you so much for having me. I'm really excited to be on this panel with a lot of really amazing colleagues here. I am, like Chris said, a postdoctoral fellow at the Human Spaceflight Lab in the School of Medicine at Hopkins. My background is actually pretty interesting. I'm trained as an anthropologist, specifically a human biologist. And so I think that I bring a unique perspective of looking at hardcore physiology, but from a humanistic perspective and looking at how physiology and behavior come together in full human systems, which I think is becoming increasingly more important as we're thinking of not just individual astronauts going to space, but we're sending groups of people. We want to have a society up in space. And what does that mean? How are people going to come together? What does that mean for their bodies? How are they adapting? What does it mean for the social relationships? And how do those things join together? So I'm really excited to be here. I'm also my research is very in-depth in extreme environments and field work and thinking about the operational aspects of it. So, we have these really great questions and they can be asked sometimes in a lab, but oftentimes you need to just go out in the field and see what happens. So thank you so much for having me. I'm really excited for the panel coming up. I guess I will also mention I'm pretty heavily involved with the Bioastronautics at Hopkins initiative. We are trying to build more structures in place to study human spaceflight and human spaceflight research here at Hopkins. And we have a really great journal club and some happy hours. And these were kind of born out of COVID because we weren't seeing each other and we realized that human connection is extremely important. And so they've kind of grown into this whole monster of itself. But talking about diversity and inclusion and making sure that everyone has a seat at the table is something that is really important to this initiative and to my work.
Fantastic. Thank you so much. And really, thank you for joining us today. It's fantastic. Next up, I would like to introduce Dr. Sawyer. She's also an MD and is the director of UC Space Health at the University of California, among many other hats she's wearing for sure. Sorry, lost my slide here, is the former Chief Health Innovation Officer for Trish. So yet another connection there. And I will leave the floor to her now to introduce her work and some of her perspectives. Thank you so much for joining us today.
Thank you very much for this opportunity, Chris, and also to the Australian Space Biology and Health Symposium. The topic of how we will live in space is a really fascinating one, and it's going to translate right back to how we benefit people on Earth. And all of us, I think, are like-minded on the panel in that way. I might have overstepped my request here. I thought we were to present a little bit about our work, so I'll do this all in a very fast time frame here. Thank you very much.
You have all the time you need. It's all good.
Okay, we have so many really important and experienced people to speak, so I'll go quickly. But I do also want to give a shout out to my Australian collaborators, of which I'm really fortunate to have had many years experience with. So speaking to them as well as to our American audience, most of us are really well aware of Earth analogs for space, and Emmanuel has deep expertise in this and can speak more to it. I also think, as do many, that space is a great analog for Earth, and not just in contributions that we see coming back to healthcare on Earth. We've seen numerous benefits from space, but I think of it as an analog for Earth in terms of remote distributed care and also in precision health. And there are many environments on Earth that we're familiar with where we need much more capability to do distributed but not diluted healthcare. An example is global health or occupations in extreme environments such as the Antarctic. Also expedition adventurers such as ocean rowers, and including my own patients at home that I'm trying to help take better care of themselves and enable them to do this. We also learned a lot about this and the needs for much, much more capacity during the pandemic, and the idea of contactless healthcare and self-empowerment. And of course, obviously, the environment of space health as we go into longer duration and longer distance missions. So there are lots of comparisons that can be made across here, and certain ones we see are really obvious. But if you look at the constraints that are really ubiquitous would be limited medical personnel, limited equipment, limited power, limited comms, voice and data, remote and isolated environments, and on and on. But so what we've done in our lab is try to sort out where we could build core capacities for space health that would apply on Earth. The parallels in terrestrial and space health needs are many. These resource constraints and potential risks, even in our high resource settings during pandemics and natural disasters, we felt the constraints. There's also a real need for individual level health awareness and timely and personalized interventions. We've got to extend our expertise and our technology and our computational capabilities to point of need. And what I mean by that is, where do you need the information? We need in-time information at the right time to make the right choice and hopefully get the right outcomes. And we've also got to understand the effect of the environment on the individual, so contextualize the information we get. So we need really to live in space and improve life on Earth broadly. We need a big paradigm shift. We've got to move from reactive to proactive strategies, go upstream on awareness and early interventions. We need more data-driven strategies and tiered models to contextualize the human data in context of all of their data, so holomic or multiomic. And we also need to have environmental generated data and population data wrapping around that human data. So we've got to enable what I call health sense to drive risk prediction, detection, precision interventions. We need to really advance our technological and cultural understanding of this to get beyond tethered models, like tethered telemedicine models. We've got to shift over to augmented, all the way to autonomous self-health and medical management. And all of this will serve to facilitate space, the space crew health and safety, but also enable distributed care on Earth. We, in our lab, feel it's really important to tackle this enormous paradigm shift or cosmic shift we're proposing, tackle it on a use case basis, so a needs-driven basis. So an example would be going upstream on medical conditions, and these are 4 upstream health statuses that we need to have a better understanding of, because they predispose to multiple medical conditions downstream. So we've looked deeply at these states of hydration, managed stress, rest and recovery, and energy balance, and are looking at what are the key sensing capabilities for the human in the environment and the computational needs to have an ability to sense early deflections and give precise interventions in each of these to prevent deteriorating into clinical scenarios. So here's a very cartoon or a graphic representation of what we're talking about, the health sense matrix for space, where we have human and environmental generated data being integrated. And this is in the spacecraft. This is in the spacesuit, which is another environment, or on planetary modules. That's another environment. All of these would be synchronously integrated LANs, so body area networks, integrated with each of these LANs as able, the local area networks, and then asynchronously pushed back and forth to mission control. Obviously, there's a lot of work to be done. We would love to collaborate with anybody who's interested in this. I really want to thank my lab and my Health Sense Matrix team, my collaborators, and Millie Hughes-Fulford in memoriam. And I also really want to thank the supporters, especially Trish, who have really empowered this work. Thank you.
Thank you for sharing that. I think you're really setting the stage for everybody in terms of, you know, what we really need to discuss and what the questions are we need to tackle. To close out this panel, I would like to introduce Miles Harris. He's a PhD candidate at the University College of London in the UK, and he is researching prolonged field care theory, including pre-hospital health for disaster risk reduction in remote environments and outer space. Miles, we're really pleased to have you join us here today. So please feel free to share some more about yourself and your work.
Thanks so much, Chris, and thank you very much to ASBX as well for including me in this panel today. I feel really pleased that I can be alongside such amazing colleagues doing amazing work. Firstly, just to say apologies for not turning on my video at the moment. My internet is hanging on by a thread, so I hope to give you a wave just after I introduce myself and the work that we're doing at UCL. So as Chris mentioned, I'm doing a PhD in risk and disaster reduction. Prolonged field care really is a military healthcare term that refers to healthcare provision in very remote environments. And this research is in collaboration with the British Ministry of Defence, the Royal Centre for Defence Medicine. But I'm primarily here to talk about a research group that I coordinate at UCL, which is UCL's Space Health Risks Research Group. We're a multidisciplinary community of researchers and practitioners who are researching healthcare in space in order to apply that research and learning from that practice to benefit life back on Earth. We collaborate with many organizations and researchers across the world, and I can see some friends and colleagues in the audience as well. Some examples being the Canadian Space Health Research Network. So we're an international research group as well as focusing on research in the UK. We have lots of research projects that are taking place at the moment, but our largest research project is an analog mission that will be taking place next spring. And never before has there been an analog mission of this nature in the UK. It's an analog mission that involves humans, and we're simulating the exploration of another planet. And the overall aims of the analog mission are to investigate interdisciplinary healthcare during the exploration of another planet. And the rationale for that is that healthcare practitioners that go to remote environments on Earth, as well as during deep space missions, are required to not only provide healthcare based on their speciality, but to also reach out to other disciplines of health as well. So my background is nursing, and usually if I'm practicing as a nurse and I need a doctor or a paramedic or a physio, I can pick up the phone or reach out and they're next to me. But obviously in space and remote environments, that's not possible. The location of the analog will be a remote and an uninhabited island on the west coast of Scotland. And because this is the first analog mission of this nature in the UK, it's going to involve 6 analog astronauts, which is relatively small. But this analog mission is a pilot, and what we're hoping is that this mission will lay the foundation for analog research in the UK and open this up to UK researchers and also over in Europe and further afield to see whether analog research can take place in the UK. So thank you very much, and I'm going to try turning on my video and give everyone a wave.
Fantastic. Thank you, Miles. And I think the most important question is, where do we sign up for the analog mission. That's, I think, the most pressing. I would like to start off the panel with a very broad question, and I think that, you know, this is actually it really goes to everybody, because this fits right in everybody's, you know, work, and especially the, you know, the people from Trish as well. What do you think is the most pressing information that we're still missing in order to really you know, enable those long-term missions and hopefully be able to, you know, provide enough safety for crew, for future tourists, and yeah, future habitation of the moon or Mars or something else? So just take it.
Well, since you called on Trish,
Yes.
I will speak first and then hand it off to the rest of my colleagues. But so we just completed a series of about 38 interviews for a Trish sponsored documentary on the space health risks and research needed. And we interviewed nearly a dozen astronauts and flight surgeons and program managers and NASA administrators. And what was really interesting, what emerged out of this, is that the further away we get from Earth, the more just even the basic needs are still not figured out. And what I mean by this is the food system. So yes, we have to make sure that our medical capabilities are able to take care of any event that may occur. But without a really good food system that will be sustainable over a really long duration mission to Mars, and we're thinking roughly in the order of 900 days, we're going to have to pre-supply the surface with food that will be dropped there ahead of the crew arriving. And the length of the time that that food needs to be still palatable and contain all the nutritional needs, we don't have that figured out. There are many vitamins and nutrients that are not stable over a really long shelf life, so on the order of 3 to 5 years. So learning about how to provide a food system that is sustainable is actually the most important topic in my mind. Yes, medical issues, radiation, the spaceflight associated neuroocular syndrome, behavior health, all of those things are important, but without the food, to me, all those things become secondary. So that is a major focus. And I think that what we learn about developing new food systems and sustainability will really impact us as we think about that for a long-term habitation of our planet here. At some point, we're going to have to figure out a better way to provide food that doesn't require using up the natural resources of our precious Earth. So what we do in space in the food system will definitely have impact here on Earth. I'll let others chime in.
Yeah, I think I agree with Dorit on the food. I participated in an analog mission a few years ago. I was part of the Hera 11 mission, and I cannot agree more that being in an isolated and confined environment, food is one of the very few things that you can control and enjoy and have a little bit of pleasure during those missions. So I think food is an absolutely critical thing that, you know, touches a lot of the risks, right? It's not only providing nutrients to the system, but also the behavioral aspect of enjoying what you eat, and maybe it brings you back to Earth, to a specific memory that you have with a family or friends. So I think food is really important. But another critical thing is the amount of data that we will need to develop systems for prediction, prevention, and personalizing medicine, right? And when we look at missions to Mars, or even further, that I was mentioning 900 plus days on a mission to Mars, given the massive constraints and the fact that we will not have access in real time to communications and to medical guidance, for us to develop these systems, we will need a massive amount of data. And as we started this panel with Chris's introduction, this needs to be a diverse data set. It needs to be an inclusive data set, so that the algorithm provides a personalized recommendation for diagnostics or treatment for a specific astronaut, so that we can provide really the same level of care regardless of the diversity or the background of the astronaut. So I think that's one of the things that we need to ensure that we start collecting. And this is where commercial spaceflight brings a new opportunity to collect this data. And I will be very interested to hear what Malika has to say about all of the the anthropology and the sociology of food and all of these things.
I think we must all be on the same wavelength, because food was also the first immediate thing that I was thinking of as well. And so like I have a unique perspective because I did my graduate work in metabolic physiology. And so understanding like body composition changes and energy expenditure and how that changes when you're doing really intensive activity and really intensive cognitive demanding tasks, and the energetic stressors that brings, and the only way to get energy back into your body is to eat. And so food is critical in terms of like making sure that humans survive, obviously, but also as someone who has done, you know, extensive work in austere environments, like all I think about when I'm in the field is my research and my food, and like, what am I going to eat for lunch? What am I going to eat for dinner? Making sure that we have a meal plan, making sure that we have like our food is not expired. It is wild the things that people will do for food that they want to eat, and the meltdowns that can happen when that food is no longer available. So thinking about the importance of food and having a hydroponic system and making sure that you have vegetables that are fresh and you can watch them grow, and then you can cut them and you get that fresh smell of, you know, when you cut greens, as opposed to having like dehydrated spinach, which is horrible. The joy that it brings to actually have that fresh food, or being able to bake bread when you don't have any of the materials to bake bread, and then you can take, you know, dehydrated materials and make bread out of it. So it's like Emmanuel had said, it's not just the nutritional aspect of it. It's not just the fact that we need energy, we need calories in order for our bodies to not, you know, fall apart, but the joy it brings, the social connection that it can bring when you're cooking together, when you're eating together, meal times, you know, the conversations that it starts, the creativity. I think that is like, you know, something that is kind of talked about, but maybe not very specifically looked at, is like, you know, the creative and innovative process that happens when you're in a spaceflight environment or an austere environment, and the importance of that, the being able to make, you know, problem solve in really creative ways when you don't have anything with you. I was at a talk a couple days ago, and someone had mentioned, Chris Leinhart had mentioned MacGyvering, and like, what is the, you know, MacGyvering is such a critical point of doing any sort of spaceflight mission, but also any sort of extreme environment mission. And like, what, you know, it's, what is it called? I guess innovation would be that, but food is at the central of that. Can you make a sandwich with only freeze-dried materials? If you can do that, then, you know, everyone on the crew is going to be really happy. It means your EVAs are going to go well. It means they're going to do the science. And like, how do you make sure that people are still eating when they've had oatmeal like 12 weeks in a row and they don't want to eat oatmeal anymore? So I think it's like really core and at the central, like, who we are as people to be eating. Miles.
Yeah.
Thanks so much. I'm in complete agreement with all the other panelists. I think food is central. And one thing that sort of it made me remind me of is sort of the stability of food, and how can we ensure that we have fresh food when we go to other planets. And what that reminded me of is also medications. And that directly applies to benefiting life on Earth. When expeditions take place to very remote and austere environments, as Malika was just talking about, such as Antarctica, often people are there for many, many months. So it's incredibly important to have medications and food and nutrition that has longevity, that will see people through to the end of their expedition. That's one of the studies that we're doing in our analog mission next spring, is an astropharmacy study that looks at how medications can be used during the exploration of another planet, and that obviously takes such a long time.
Yeah, thank you everybody for these great contributions. I think an interesting part, yeah, please go ahead, Anna, if you have another comment on this.
Oh yeah, I was just going to follow on that discussion, if it's all right. First of all, I really love what everyone's said so far. In my mind, I don't really separate food and hydration. So nutrition and hydration are tightly linked as a model. It's just fuel for the human. The rowers go through really significant similar problems. They have to pack all their food. They're unsupported, no resupply. And the longest row I've ever covered as an expedition medic is 6 months, but on a 6 by 23 foot rowboat, when you need all kinds of equipment, there's not a lot of room for food. We have done some growing of sprouts at times, but mostly they have to use what they take. But there are many reasons, as with astronauts, why just eating is a problem. There's motion, there's emotion, and then there are also just you lose or change your taste and smell. So these are big problems. One of the things that we did in our approach to building a health sense matrix or mapping it was we did a lot of stakeholder interviews, astronauts and other stakeholders. And what we learned from the astronauts is they are really interested in having more gauges. They don't have gauges for their body. The least monitored part of the entire spacecraft system is the human, which is very critical and vulnerable. So looking at monitoring the system, which already has elaborate closed feedback loops just to keep the spacecraft running, the least monitored portion of that is the human. So they're interested in more gauges so they can make informed individual choices about their health. This is a fine balance, though. They already feel over-monitored in some ways, so it needs to be non-intrusive and it needs to be valuable information they're getting back. But they would love more in-flight information about their health. Most of the monitoring that happens to them in mission gets sent to mission control, and very little of it is used for in-time decision-making for their own self-health. Kate Rubins would love to know more about sleep. She'd love to know more about hydration and energy balance and those things that she could use on a regular basis to keep herself optimized. So I think really we're talking about very similar things, whether we pick a use case of food or a use case of some of the other vulnerabilities they'll have. We really need to get to more in-time, non-intrusive and individualized information. And as Emmanuel said, it's going to be incredibly difficult. It takes a lot of data to do that, but it's going to need to be done in an on-prem fashion. So those are and it needs to be relevant data, not all the data we can collect.
Right. Yeah, that's also true, right? Because we can always collect more data, but then we're not having any control groups or anything that this is important. Malika, did you have another thought on this?
Yeah, I don't know if this is taking this question maybe like off track here, but you know, thinking about self-monitoring, you know, I feel like a lot of your social cues and your own personal cues of what you believe is normal shifts super dramatically when you're on, you know, a space flight mission or you're in an austere environment. Your normal changes, right? You're acclimatizing, you're changing. But if you have some sense of, I'm really dehydrated today, or I'm not getting enough sleep, or I know I want to eat, I don't, like, nothing feels appetizing, but I have to have more calories in my system. You're allowing the individual to be autonomous in their own success. And so it's allowing for a long-term autonomous and more sustainable system, which I think Dorit had mentioned before. We need a sustainable system. And like, it's fine if the rockets are sustainable, but if the people that are on the rockets are not sustainable, you're not going to have a successful mission.
I totally agree, and I'm sure so is everybody else. I think one other part to this, where a little bit my I guess third heart of engineering kind of starts coming up a little bit, is also that we are actually, in order to tackle these challenges for sustainable food and also fluid resources, we're also needing this diverse background in biologists and engineers, because we know that we can drop something probably on a distant planet, but it needs protection from the environment in all kinds of fashion, both environmental control for temperature, but also obviously from radiation. So those kind of things, the diversity of the groups developing this is really kind of put to the test there as well. But yeah, more comments, please go ahead.
I was going to just follow up on what Malika was saying. I think it's really important that we know that these need to be learning and adaptive systems, because the baselines will keep changing. And we've seen that new set point at 6 weeks for fluid shifts, et cetera. We don't know what's going to happen on longer duration missions. So I think the adaptive learning component is very, very important. I also wanted to point out that a lot of these conditions are preclinical or asymptomatic. So you can be hypohydrated. By the time you're thirsty, you're dehydrated. So a lot of the preclinical or the windows of opportunity are asymptomatic. And that's why we need gauges. And there are times where you just simply might be depressed and not feel like eating, but if you knew that you were losing ground on your energy balance, that might be enough motivation to have you do what you need to that day nutritionally.
And I think, so since we've already touched on this a couple of times now, like the, you know, what you said, like the need for gauging and the hope for precision health, I guess the question there is, and I do understand that, you know, Trish has really been a front runner there. How do we collect all that necessary data to make this happen, that we have enough data, even from that still unfortunately small number of people that is traveling, but also how do we build the incentives that future tourists are really interested in, you know, having all these monitors so that we can build these gauges and build these baselines to know what is good and what is maybe bad in space?
Yeah, I can take that one. So first we need to understand how different are the commercial spaceflight participants from your professional astronauts, right? From your agency astronauts. So the commercial spaceflight participants are actually paying to go into space, right? So we need to make sure that everything that we add to their mission, to the main objective of their mission, it does not take a lot of time. It does not take a lot of training. It does not take a lot of mass and volume that they have to carry with themselves, because that will be to the cost of something else that they want to bring personally as part of their mission. So the program that we have been developing at Trish, really the baseline of that, the foundation, is to make these measures as unobtrusive as possible. Even to the point that the crew members at one point in an ideal feature will be measuring all of the parameters that we need without them even realizing. So you know, any project that you develop, any new process that you want them to do in the mission needs to part from this premise that it needs to be as easy and as less burdensome as possible for them. Now, the challenge with doing this is that of course you want to collect relevant and you know, valuable data, right? So you need to make sure that whatever you select, it is, yes, it's easy to use. The crew will likely select because, you know, at the end of the day, they have to consent to participate, right? So we need to make sure that, one, they consent. Number two, it's easy for them. And number three, that the data that we'll collect is streamlined, it is standardized, and it is valuable. And again, replicable regardless of the commercial spaceflight provider and the mission, which I think that is one of the biggest challenges, because we see missions like the Inspiration 4 mission. It was a 3-day orbital mission, right? They didn't go to the station. But we are seeing now Axiom missions next year, for example, right? And they are going to the space station. So this is now a longer mission. Now you need to start looking at different risks from the human physiology curves of adaptation that we know. And how do you standardize that given the big difference of vehicles, of design reference missions and destinations? So I think that is the most critical part that needs to be considered for collecting data in commercial spaceflight.
I think Emmanuel hit the nail on the head. We call it the value to nuisance ratio. You have to deliver more value than you create nuisance. And if the VNR, we call it, if it's greater than 1, you've won. If it's less than 1, you're done. And it's why we've learned this from healthcare technologies, whether they're wearables or we're setting home monitoring or we're using health apps. If they don't deliver more value than nuisance, they're gone in 6 months in that patient's life or sooner. So I think that's the main point we have to do. And that's very individualized. What's of value to the individual and what's of nuisance to the individual. And nuisance could even include threat or fear. Like a lot of astronauts don't want a lot of data collected and sent to mission control that might impair them for qualifying for the next flight. So we have to understand individually what is value and what is nuisance.
And I think another thing of, you know, we are living in a time of paradigm shifts when we're thinking about technological advances. And so another thing that I think Trish is doing really admirably is setting the precedent. If you are doing human spaceflight, it includes monitoring, and this is what the new normal is. And I think that we have a really unique and exciting opportunity as spaceflight professionals to kind of set the tone, you know, making sure that, you know, we are working with our stakeholders, with, you know, both professional astronauts and commercial astronauts to figure out what works and what people are happy with, but also making sure that folks know that doing spaceflight is not just a joyride. You know, you get to contribute to humanity by providing your data, which is a big it's a big mental shift to make, especially for a lot of consumers. And I think it's going to take a lot of really good marketing. And I think it goes back to Emmanuel's earlier point about we need a lot of people on this team. It can't just be us scientists and engineers. We need PR people, we need marketing people, we need people who are able to tell the story of what does it mean to be in space? What does it mean to contribute to the rest of the world by providing your data?
Malika, thanks for bringing that up. So we've learned some things. We were successful in completing one mission with the Inspiration 4, but we have now worked with Space Adventures crew, Axiom crew, and there's other spaceflight providers that are coming on board as well. And it's really interesting to see the range of responses when we discuss with potential participants willingness to participate in research. And I think that what you said is really important. We have to do a better job explaining why these research studies are so critical and their participation is needed. Some people are just uncomfortable thinking about themselves as guinea pigs. And so you have to consider their level of comfort and provide them with an opportunity to contribute in a way that doesn't cross borders or lines for them in terms of comfort level. But I also want to say something about the nature of the studies. So every individual that's going to space, obviously, it's bought and paid for access. And unlike government sponsored astronauts who are paid for by tax dollars, feel like they need to participate in research studies because they're up there to do a job. Commercial spaceflight participants go up for many different reasons, and so we have to be respectful of that. I do think about the fact that every person goes up with a particular agenda. So Axiom crew just put out a whole list of experiments that each of the crew members is doing, and it's really admirable. But it's important to standardize because a lot of that data may be kind of like one-off, may just kind of be a marketing advantage for certain products that are going to space. But we want to make sure that whatever opportunities come up, that the data and the experiments that's done actually contribute to a knowledge base in a meaningful way, instead of just, I almost see it like the Wild West, anybody kind of does whatever they think is appropriate. And so we were really glad that the Inspiration 4 crew was willing to listen to us in terms of like, this is what a reasonable experiment in terms of the duration of the mission, what we are expecting to see based on what we know, what happens to a human over many years of studying humans. So in a 3-day mission, we're not expecting to have major changes to the bones and muscles. And so we're not going to be prioritizing those, but we are expecting to see sensory motor adaptation, as you well know yourself. So those are the experiments that we focused on. And certain hardware, what I mean by that, medical devices are never going to be appropriate for spaceflight. So you have to go for things that are miniaturized, easy to use. And so we bring kind of a wealth of knowledge to help people who want to engage, to make sure that the experiments that they're carrying out actually contribute in a meaningful way. And Emmanuel and his team really put together a nice capability that allows all that data to be put into a database so that the research results can be mined, can be looked at, can be queried in the future as we add additional samples, additional people added to the database across different mission providers. So the SpaceX customers would be put in the same database as the Axiom passengers, protecting everybody's discrete data sets, protecting people's privacy, but in a comparable way so that you're able to compare apples to apples and really aggregate the data. And as you know, Malika, as a scientist, the more you can compare across experiments, the more confidence you have in what you're seeing. So the call to the community is let's standardize. And Trish is really trying to do that right now.
And I think the real benefit of having a central kind of pool and a central center that captures all this data. I think we've seen this, time and time again, because as you said before, right, if everybody just does something and nobody knows where this data is stored and how to get to it, especially because we have such few participants to date, at least, this is really going to be crucial. So, I mean, really, thank you all for your vision in this and for really putting this into motion, because it's going to be absolutely crucial for anything going in the future. I want to shift a tiny bit here, for the last 15 minutes that we have, and touch on something that Emmanuel mentioned briefly, but I think it's going to rope in a lot of the other panelists. The difficulty, as in science always, apples and apples, etc. The difficulty with the different launch providers, both looking at suborbital, orbital, and LEO, and then going further, the difficulty in the data and how to compare it. So here's my question. How could possible Earth-based analogs help with, I guess, creating that better baseline and understanding better what of the data we see in these different kinds of missions is more an outlier, or what becomes more reality and can be kind of put to the test and help gauge things again?
Yeah, I can start with that one. So I think whatever you do to collect data, even if it's spaceflight or in the case you're mentioning terrestrial analogs, everything needs to start from the premise that there needs to be a research-driven program, and there's to be a research-driven question, right? That you want to answer on a specific analog on a specific spaceflight. And once you have that, you need to understand, of course, the different physiologic adaptation. And I'm going to talk first about commercial spaceflight. The different physiologic adaptation stages, you actually see some of them in suborbital flights, even given the short duration of them. And then you start seeing others in commercial spaceflight, or in spaceflight in general. And Dorit was mentioning, right? Initially, you see the first spike is sensory motor, and then you start seeing cardiovascular, and then you start seeing bone and muscle. So your research questions need to be first driven from what we know on human physiology, and then you need to adapt them based on the constraints that you have on the provider, on the duration of the mission, and the destination of the mission. Now, some of those questions can also be tested in terrestrial analogs, right? Some of them, for example, behavioral, team dynamics and team composition. So there's some of those questions that can also be tested in analogs. So the next layer would be what technologies you want to test to answer those questions that are the foundation of your research program. So once you get to that stage, you can decide if you want to test them in terrestrial analogs or in commercial spaceflight. And once you get to that point, then you can start standardizing what you want to collect, right? Do you want to collect, say, heart rate? What device were you going to use, or what are you going to be your thresholds? Where are you going to be your requirements? Does this need to be an FDA approved device or not? So I think that's a good way to standardize the data that you collect, regardless if it's a spaceflight analog on Earth or if it's real space. And then you can have data that for some data sets, you can actually compare apples to apples, even if it's real spaceflight or if it's simulated spaceflight. So I think as long as you have a good way to standardize and to put a lot of annotations of the data, a lot of times it's very useful to put how the data was collected, if there was an issue with the data, so that when people go back and, in the case of Trish, go back and submit a data request, they can understand all of the context where the data was collected. So I hope that answered your question.
I would want to add also that once the standardizing has been completed, the next step is to increase your N as much as possible and make sure that you have a wide variety in who you are collecting. So NIH, NSF both require that you submit and I believe NASA as well, submit if you're doing any sort of ground-based studies, who exactly you're collecting for your subject base and who's going to be in your subject pool, to make sure that you are not accidentally introducing bias into looking at a system. So, I think examples from high altitude physiology. You know, it's been studied for decades and decades, and it shows that people living in different areas of the world are adapting and acclimating to high altitude changes differently. And it has to do with, you know, things that happen in early childhood. It has to do with environmental structures. It has to do with nutrition. So are there all of these things that are introducing variation? And I mean, that's what makes humans amazing, is we have all of these really fantastic, adaptable, flexible ways of responding to an environment. But if we're only studying a small group of people, it means that our science is flawed. It means that the capabilities that we're developing in order to look at the answers and making sure that we're keeping people safe is only going to work for a very small subset of people. And so it needs to be standardized, and then we need to have a diverse group of people that we're looking at.
I think Dorit, you also had another comment.
Yeah, exactly, Malika, and that's why we think that looking at commercial participants provides that opportunity. So the NASA astronauts, I mean, there's certainly a lot more diversity these days, but they're incredibly healthy people. And so it's learning more from the edge cases, if you will. As a physician, I'm sure Ainur and Emmanuel both know, if you're taking care of healthy people, you don't learn a whole lot. And so we have healthy people in an unhealthy environment, and with time they may become unhealthy, but for the moment they're pretty healthy. So as we prepare to think about possibly these healthy people becoming unhealthy with long duration space flight, let's study those edge cases. I don't mean to say that necessarily all commercial participants are going to be unhealthy, but they're on medications, they have existing conditions. And so that's the advantage. Looking at an individual like William Shatner, who's 90 years old, he's probably on some medications. I don't know for a fact, but he probably is. So let's see how he responded to the space environment being on those medications. So we will learn a lot from studying those edge cases. That's number one. The second point is what we are collecting environmental data from each of the vehicles. So in answer to your question, Christine, we will know the CO2 levels, we will know the temperature, we will know the altitude, we will know the radiation exposure, we will know all of those things, that what G-forces were experienced by these individuals. So being able to combine the physiological data with the environmental data is unprecedented, because think about it today. For your healthcare here on Earth, I'm sure Ainur and Emmanuel, when they take care of patients, they wish they could go into the home and see what they're eating, how they're sleeping, you know, what is the temperature that the thermostat is set to, because that can actually impact their hydration status, which Ainur was concerned about. So having that complete picture with the environmental setting in one place where you can look at all of those things together, it actually takes terrestrial medicine to a new level.
I agree. It's that is really a huge additional value, yeah, the combination of all that data. And yeah, I agree. So from my own experience, sometimes you would want to love to go to their homes. But yeah, go ahead.
Yeah, these are all great points. Following up on Emmanuel's point of needing a research question, for me, I'm more on the front lines of healthcare in terms of looking at the translational or the impact. So I think of it as use case driven, but it's the same idea. There has to be a so what factor that you're going after. And I do really feel we need to work in the context of having human generated data in combination with the environmental generated data. And that's why we're striving on Earth to build out real world evidence models and capabilities. And we also need to break down the walls between health data and medical data. Our bodies, we exist on a continuum of wellness to illness and back again, but our data and our devices don't move with us. And I think we should look at using the same types of integrated multi-parametric sensing for the pre-flight era for the astronaut into the in-flight and then post-flight and maybe on into retirement. So we see the continuum and start breaking down these segmented approaches. I wanted to make one more comment about the standardization. It's really unlikely that there will be a single database. So, you know, it's very admirable to build database capabilities, but we've seen this over and over where each company wants to be the platform. And what's most important is what Dorit was saying, is we need standards so that we can create compatibility and comparability across the data sets that are built. And it's the same thing we've seen in healthcare and the importance of HL7 and Smart on Fire and those standards that will allow us to not try to put everything into one database, but to be able to leverage and intersect and communicate with other data sets as we need to.
I fully agree, and sadly, you know, standardization and comparability is obviously an issue in all aspects of science. So I have more of a cell biology background, and it's the same thing. You can, you know, look at 7 different papers that uses either simulated or real space flight, and it's the same difficulty. How do you compare things, and what are the conclusions you can draw? So it is a huge challenge. Miles, you had another also a comment.
Just very briefly, because I don't want to repeat what others were saying, but I was thinking that it's vitally important to collect lots of data about not only the acute care needs, but the long-term care needs as well. For me, as a nurse and a risk and disaster scientist, being on the cusp of the commercial space tourism industry is incredibly interesting. Because exactly like other colleagues on the panel have been saying, astronauts are largely healthy people. But as we move into this new dawn of space exploration and space travel, we will have people that have long-term healthcare needs, and that's really, really important that we meet those healthcare needs. There are 2 sort of branches to that. There are physical healthcare needs, but there are also psychosocial healthcare needs as well. And that brings me back to the point I was talking about in my introduction about interdisciplinary healthcare practice. The model of healthcare on planet Earth is very much compartmentalized into different health disciplines, whereas in very remote environments such as space, at the moment, we don't have that infrastructure and resources to meet those healthcare needs with a multidisciplinary team. It needs to be an interdisciplinary healthcare practitioner that's trained and experienced enough to be able to meet all holistic care needs, right from physical all the way through to psychosocial.
I think that's absolutely agreeable. Thank you for that. I want to take the last 4 to 5 minutes of our session and be very conscientious of everybody's time and schedule to give everybody another minute and a half, if you will, to kind of maybe summarize a final thought after this discussion, or in general. I know we've kind of come to really brought out that the future of human survival in outer space is heavily hinged on behavioral and social psychological events, but also specifically on food and nutrition in general. So I'm happy to hear some final. Go ahead, Malika. I'm just going to call you out.
Okay, so I would say I want to end on like a kind of a positive note. Humans are extremely good at adapting to really, really terrible places. We have successfully adapted to almost every single environment here on Earth, with the exception of a desert. That is a whole climate change discussion that we can have another day. But we should have confidence in our ability to adapt and change and make a home in somewhere as unfriendly as space. But it requires lots of different minds coming together. It requires a lot of work, and it requires rigor. I think that we're in a really exciting time in spaceflight where kind of the door is open for anybody. But I think that it's important that we understand the responsibility that we carry as scientists and as medical professionals and as engineers and as people who are walking through the door for the first time, to make sure that we are setting up a structure that is sustainable and can be continued into the future.
Thank you. Any other thoughts, comments?
Just following on what Malik is saying, think outside of the envelope and think outside of what traditional people have done, because it's usually in those areas where you find the new ways to do things and really the solutions that we need for these extremely challenging missions to Mars, and even going back to the moon requires thinking out of the box, and in some cases going against what a lot of people think that is the norm or the way that things should be done. So don't be afraid to think outside of the box, and really that's what we need, innovators, especially for the younger people's coming into this field. And also think about diversity in everything that you do. I think it is as important as having a multidisciplinary team of people looking at the problems, like Malika was saying, but it's also as relevant as and important to think about diversity and how these might be different, considering the gender and the demographics of people going to space. And the last one, reach out to us, reach out to Trish if you have any ideas, especially if you're a young professional. We have postdoctoral fellowships, we have the Academy of Bioastronautics, we have a bunch of meetings and resources for you. So don't hesitate to ask, and we will be happy to hear from you. Thank you.
Hi, I want to thank you first in case we don't get time to, but this was really, really great and well orchestrated by the interviewer. So thank you. I want to just leave a note of what we've all said this already. This isn't novel, but I think we need to focus really hard on integration and integration across distance. So like in our model of concentric lands, local area networks with asynchronous push to mission control. So distance, across distance, we need integration. We need integration across time. So the astronaut's journey from early on in their lives, integrating information about their health history and even their multi-omic data we'll be gathering, and then on across pre-flight, in-flight, post-flight, and on into retirement. So integrating these information systems across time and integrating across systems. This is really important. We talked about it earlier, the ability to be compatible and comparable by using standards. Also making sure there's compatibility with existing systems and planned systems in NASA and in the commercial space entities. And we need astronaut consented healthcare providers also to participate in that entire community of information, because astronauts do, even current astronauts, get information, generate information in the healthcare world outside of NASA. We also need to have some sort of integration with external researchers, academics and industry, and of course the commercial space companies. And I really think that when we talk about integration, we should keep it as broad as we can in terms of what does that mean and who are we integrating with and who are we locking arms with. Across disciplines, yes, but also within the body, looking more at systems biology rather than compartmentalized cardiovascular versus neuro versus optho, et cetera. And NASA is really taking a strong lead in that in XMC and HRP, so that we're looking at more of a holistic model that respects and recognizes the interdependencies. And I would love to reach out and have more communication with anyone out there who's interested in the work that we've talked about. Our group is the UC Space Health Program. We've integrated UC researchers and innovators across the University of California system. And we are really open and inclusive and would love to contact others.
Thank you so much. This is really fantastic. Dorit, do you have some final thoughts?
Yeah, you know, I grew up in the 60s and I used to watch Star Trek, and I never ever thought in my lifetime that I would see regular people going to space, and to see William Shatner go to space. To me, that was an incredible moment. And space has always been ahead of humanity, at least even in science fiction. You think about the Star Trek crew, what they envisioned, how diverse they were. You know, the first kiss on screen between a black and a white, that raised a lot of eyebrows back then, but today we wouldn't even think about it. So space has always been ahead of the curve because we imagine a future that's better than the future of today. So it's exciting for me as I'm actually seeing in my lifetime that future come true. So I really send a lot of kudos to the organizers of this meeting and how international this is. A lot of the meetings that I speak at tend to be too focused on, you know, certain demographics in terms of communities, and this is incredibly wide reaching. So I really give a lot of credit to you. So thanks for having us.
Thank you so much. Really appreciate the comment, and it's really, yeah, our hope to keep growing this throughout the next years and making this more and more international, really. Thank you for that. Miles, you can have the last comment.
Well, thank you. And I'd just like to actually say Thank you. And just like to say to thank you to all the other panelists, really, because they must be on the same wavelength as me. Particularly what Emmanuel was saying about diversity. I think diversity is something that that we need to celebrate, and that space really is something that unites us all. And we've said this throughout the panel today. That we need a collaborative and inclusive approach to meet the challenges of space. And not only to live in space and to survive in space, but to thrive in space as well. So thank you all to the other panelists and the organisations that they represent for being so inclusive. And I really hope that I get to work with all of you in the future. Thank you very much.
Thank you. And really, it is my great pleasure, and it has been an incredible honor to discuss the past hour with all of you. Thank you so much for making time today. I know that everybody has super busy schedules. I think that our audience and those that are viewing the recording later today are really going to enjoy this. I suspect there's going to be a lot of emails coming into everybody's inbox for requests for collaborations. I personally feel really inspired, and I hope that everybody in the viewing audience also goes back to watch each of your individual videos, which I know you've taken great care and great effort in putting together. So thank you also for that. And with that, I will close the recording for today. Thank you, everybody, and please have a good rest of your day.
Bye, everybody. Thank you
So much. Thank you, Chris.
Bye.